Let's go and talk about graphing a easy logarithmic function versus a hard logarithmic function. Now, I understand, ladies and gentlemen, you might be looking at these two examples and say they're both easy or they're both hard. I get it. It's all subjective. However, a lot of students will make a lot more mistakes on the hard example I'm going to go through compared to the easy example. So that's why I want to work through these step by step, because they look very, very similar to each other. But one is going to be much easier to compute, and the other one, a lot of students will make mistakes. So let's go through how to graph a logarithm from the very basics, step by step, so you can see how to approach the easy one, as well as what to do when you have a hard one. But when I'm teaching graphing logarithmic equations, I always tell students there's one thing that you need to make sure you understand, and that is going to be the parent function. All right, so when we want to apply transformations, you can see these are being, these have some transformations. We need to understand, well, what does the graph look like without any transformations? So without any transformations, doesn't matter if it's the natural logarithm, logarithm base of 7, they're going to have these characteristics. The first characteristic is a x-intercept at 1, 0. The other characteristics is we're going to have a vertical asymptote at x is equal to 0. Okay, so this graph is going to be approaching this vertical asymptote, but it's never going to cross. So once we have the parent function identified, we're like, okay, we got it. Now we need to understand what are transformations. Now, when we're first learning transformations, a lot of times we talk about this format of a times log of x minus c plus d. And again, this is for any function. These transformations are going to be the same. A is a vertical stretch or compression or a reflection about the x-axis. D is going to be a vertical shift up or down, and C is going to be a horizontal shift left or right. Now, a lot of students will still make mistakes here because they'll say x minus 4 is going to be 4 units to the left because they see a negative. But it's important. This is x minus c, right? So if I actually wanted to understand what the transformation is of this, a lot of times what I use is extra parentheses, x minus c. So notice when I'm using those parentheses here, I'm recognizing that c is actually a positive 4. So what that's telling me is I'm actually shifting the graph 4 units to the right. A lot of times, just to help students remember this, I just say whatever's in the inside, you're just doing the opposite. So if you see negative 4, that means 4 units to the right. So what's important though, when you are graphing this, you have to make sure that you not only move the x-intercept, but you also move the vertical asymptote. All right, so let's go ahead and redraw our x and y axis. I originally had an x-intercept at 1, 0. Now 4 units to the right, that would be 5, 0. So 1, 2, 3, 4, 5. And then my vertical asymptote was x equals 0, but now that's shifting over 4 units to the right. So 1, 2, 3, 4. That's going to look like this. And now I can go ahead and sketch this graph. So the graph is going to maintain the exact same shape because the only transformation was a horizontal shift to the right. Now it's going to look over here because a lot of students will just draw the exact same graph over here. But there's something important about our transformations. And sometimes we teach this at the beginning. Sometimes we go through some basic examples and then we get to the more difficult examples. And that is understanding when we have a B, right? Notice how I went from A, C, and D, because those are like your basic transformations. Most students understand, they can be applied to all functions. But once we get a little bit more advanced, we talk about B. So A times the log of a B times x minus c plus d. All right, now notice A is multiplying by your logarithm, B is multiplying by the x minus c, right? So if A is your horizontal stretch or compression, reflection about the x-axis, B is going to be your horizontal stretch or compression and your reflection about the y-axis. So to understand our transformations, what we first need to be able to do is rewrite it so it's in this format. Notice I have 4 minus x. That is not in that form, right? Remember when I was trying to identify the transformations over here, right? I did x minus, I put parentheses so I can easily identify what my c is. I don't know what my c is. Sometimes students will say, oh, your c is 4 or it's negative 4, make things up. Well, before we make assumptions, let's write it in the correct format. So log, I'm going to swap the x and the 4. Note that this is a positive 4 and that's a negative x. So I have to rewrite it as a negative x plus 4. All right. Now, again, it's not 4 units to the left because it has not in this format yet. And what I mean by this format, we have to have B times the quantity x minus c. So what that means is I need to factor out whatever coefficient I have here for my x. And in that case, it's going to be a negative. So what I'll have is y equals a log, factor out the negative. Now that's going to be an x minus 4. Ah, okay. So now something interesting is happening. Yes, I am shifting the graph 4 units to the right, just like I did over here, right? You could use those extra parentheses if you wanted to. I'll put them in red, right? So we can say, oh, okay, 4 units to the right. But then now also, I have a reflection about the y-axis. So the orientation of this graph is going to be a little bit different. So let's look at how that would work and how that would look at, because a lot of students will make mistakes by following the transformations in the wrong order. We don't want to shift it 4 units to the right and then reflect it about the y-axis. Okay, so there's our x-axis, there's our y-axis. When we're kind of thinking about order of operations, you're going to multiply this by this negative before you're going to be subtracting the 4. So what I'm going to do is I'm going to take my original parent graph, okay, and I need to reflect it about the y-axis. So my original parent graph would look something like this, okay? Then what I'm going to do is reflect it about the y-axis. Now the cool thing about that is my x-intercept, I don't know why my graph looks like that. I'm sorry, not my x-intercept, my vertical asymptote is not changing, right? That's still right here. So if I have that graph originally was looking like that, if I reflect that about the y-axis, the asymptote did not change. Now I'm going to take this graph and shift it over 4 units to the right. So I know my vertical asymptote, a lot of times I like to move that first. So let's shift that over 4 units to the right. I'll actually use red like I did in the other example. So 1, 2, 3, 4. That is going to be my vertical asymptote. It's kind of hard to make things nice and straight. Then I'm going to take my y-intercept, which is at -1, 0, and shift that 4 units to the right. So that's going to be 1, 2, 3, 4. And I want to use blue actually. So therefore it looks like that. And there we go. And that, ladies and gentlemen, is what that graph is going to look like. So again, a lot of students will make mistakes on both of these problems for many, many different reasons. But when we're going into the teaching, this would be an easy example, and this would be a more difficult example I would like to approach with my students. So if you need more help with graphing and understanding logarithms, then check out the videos I have for you down below. Or if you want more examples of easy versus hard, then check out the next video I have for you here. Cheers.